Welcome to today's deep dive. We are looking at a very specific stack of sources today.
Yeah, just a really short snippet, honestly.
Right, it's a translated snippet from a recent Nature publication, and it's focusing entirely on immunology and aging.
Which is a huge field.
Huge. But our mission today is to figure out if this one single explosive sentence hidden in this report could, completely change how you think about getting older.
It's a pretty bold promise.
It is. So, okay, let's unpack this. Because while the source is just this brief translated excerpt, it comes from Nature, which is, well, it's one of the most prestigious scientific journals in the world.
Oh, absolutely. I mean, getting published in Nature requires rigorous peer review. Your data has to be reproducible.
All right, they don't just publish anything.
Exactly. So when they publish a claim this bold about human biology, it's not a fringe theory. It's a major discovery that demands our attention, because it directly challenges these long-held assumptions about how the body actually degrades over time.
So, what does this all mean? The star of this report is the adult thymus,
Mm-hmm.
which sits right behind your sternum.
Yeah, right in the upper chest.
Right. And to me, it sounds less like a generic organ and more like we've discovered a hidden master clock inside the body. Or like a military academy that dictates exactly how long the war can go on.
That's a great analogy. And what's fascinating here is the absolute certainty in the report's language. I mean, the core claim states clearly that the health of the adult thymus actually directly determines the length of a person's lifespan.
Okay, wait, directly determines.
Yeah, it's directly.
That is a massive definitive claim. I mean, usually when we look at longevity, we're tracking a really messy combination of factors,
Yeah,
right?
diet, genetics, all of it.
Yeah, like telomere shortening, cellular senescence, metabolic pathways. To say one specific gland behind the sternum directly determines your lifespan, it feels almost too simple for human biology.
I get that. And that pushback makes perfect sense because, well, we are trained to look for complex webs of causation.
Right.
But let's look at the actual mechanism here. The thymus is where T cells mature. It's literally the training ground for your adaptive immune system.
Like the military academy.
Exactly like that. When you're young, it's highly active, pumping out these naive T cells ready to recognize novel threats.
Okay.
But as you age, the active tissue is actually replaced by fat. It physically shrinks.
See, here's where it gets really interesting for me. Because we've known the thymus shrinks. It's a natural biological process called involution.
Right, well documented.
But we mostly just assumed it sort of retired early because its primary job was done during childhood, once our baseline immunity was built up.
And assuming its job was done is the exact blind spot this report addresses.
Oh, wow.
Yeah, this raises a really critical question. What actually happens when that fresh T cell production drops to near zero?
I'm guessing things start falling apart.
They do. Without those new immune cells, your body eventually loses the ability to recognize new mutations. It can't clear out those senescent cells you mentioned earlier or, fight off novel pathogens.
So your defenses are just entirely compromised.
Right. You don't die just because your overall system gets quote-unquote tired. You die because your immune reinforcements literally stop coming.
That is wild.
The complex web of aging becomes fatal specifically because this one central command center shut down its operations.
So for you listening right now, this is a massive paradigm shift. I mean, your ultimate lifespan isn't just a generalized full-body decline or some random roll of the genetic dice.
Not at all.
It is fundamentally anchored to the functional health of this specific entity. The rate at which your thymus degrades is essentially the biological mechanism that caps your time.
If we connect this to the bigger picture, it reminds us that sometimes the most profound scientific breakthroughs don't actually require rewriting all of biology.
Right, they just find the actual choke point.
Exactly, they just require identifying the true bottleneck. I mean, the sheer complexity of a human lifetime and all the various ways our bodies eventually break down can actually be traced back to the structural integrity of a single gland.
It really all comes back to that central military academy closing its doors, which, leaves us with a pretty wild thought to mull over.
Yeah.
If the adult thymus is the definitive biological timer for our lifespan, and we know exactly where it is and how it physically degrades, I mean, how long until we develop the technology to simply scan it?
Oh, that's a fascinating question.
Right, to literally read the time left on your specific clock based on its tissue density. And if you had the chance to look at that scan, would you actually want to know?